guys, so in this video today we're going to look at calculating momentum or calculations involving momentum. So the example we're going to do is the 2021 ordinary level exam question. Okay, so let's read through it and let's get started. So a toy train has a mass of 133 grams and is moving along a track of 0.05 meters per second to the right. It collides with trolley Y at a mass of 46 grams, which is at rest. The two trolleys stick together and they move down the track. And the first thing we're asked to do is find the initial momentum of trolley X. Okay, so we're just going to start off by highlighting the values that we think are important. So first off, what we're looking for here, so we're looking for the initial momentum of trolley X. So it's good to have that highlighted. And let's look at the information we're given. And any values we're given, we'll write the corresponding letter above it. So the mass of trolley X is 133. So I'm going to write M subscript X for that. So the mass of X. And then we're told that the velocity, the initial velocity of this, so that's the velocity before the collision, is 0.05. So U for initial velocity and X again because it's the velocity of trolley X. And then it collides with trolley Y, which has a mass of 46 grams. So we're going to just write our mass MY, mass of trolley Y for that. And we're told that this one is at rest, and we know anything that's at rest has a velocity of 0. So the initial velocity of trolley Y is 0. And the two trains stick together and then they move off. Okay, so we're asked to find, so let's just write up what we know here. So before I even do the question, I'm just going to write this all at the side for myself. So 133 grams. I can see that the initial velocity is 0.05 meters per second. The mass of trolley Y is equal to 46 grams. And then your velocity of trolley Y, in case we need it, is 0 meters per second. Okay, so before I even look at the question or figure out what I need to do, I'm just going to look at the values that I've written down and make sure that everything is in the correct units. So grams, we know that mass is always measured in kilograms in our questions, so I need to change all of my grams into kilograms. So how do I do that? I divide my values by 1,000. Okay, so I'm going to take my values and divide them by 1,000. So that gives me a mass of trolley X. So that's equal to 0.133 kilograms. And then meters per second, that's fine. And then my 46 grams, divide that by 1,000 again to change it into kilograms, and that gives me 0.046 kilograms. Okay, so I've made sure all of my units are fine. Let's check what the question is. So the question says, calculate the initial momentum of train X. Okay, so to find momentum, we need an equation for momentum. That's the first thing that we do. So we go to our formula booklets and we look at page 51 of our formula booklets. And we can see at the top of that page, we have a formula for momentum. So momentum, P, is equal to your mass times your velocity. Okay, so from here I have my equation. I want to find the initial momentum, so that's the momentum before the collision. So I substitute in my values before the collision for trolley X. So the momentum of trolley X is equal to the mass of trolley X, 0.133, times the initial velocity of trolley X, 0.05. Okay, so we're just going to multiply those values together now. 0.133 times 0.05, and that gives me a momentum of 6.65 by 10 to the negative 3, if your calculator says it that way. Or we can change that to 0.0065. Okay, so our momentum is 0.0065. And then our unit here is kilograms meters per second. Okay, so that's our momentum of trolley X before the collision. So that's part 6. Okay, let's look at part 7. So part 7 says, calculate the speed. So we want the speed of the 2 trains after the collision. So we're told that the 2 trains collide and they move off together. So they're moving off at the same speed. So we need to find the speed after the collision. And this is where our conservation of momentum comes into play. So we need to use what we know about the conservation of momentum to find this. So what do we know about the conservation of momentum? I know that whatever the momentum is before the collision, momentum before the collision is equal to the momentum after the collision. Okay, so now by writing this down, I have an equation. So as soon as you have an equal sign, you have your equation here. So momentum before collision is equal to the momentum after the collision. Okay, so now we just need to fill it in. So what is the momentum before the collision? So that's the momentum of trolley X before the collision plus the momentum of trolley Y before the collision. And that's equal to the momentum after the collision. So the momentum after is going to be, let's say, momentum of trolley X plus Y because the 2 of them are moving off together. Okay, so let's try to fill in from here. So again, you don't need to have that line down in P's. It's just so you guys can see where I'm getting these values from. So the momentum of trolley X before the collision, well, we just found that, didn't we? So that's 0.0065. And the momentum of trolley Y before the collision, well, it was at rest, so it had no impact. So that means momentum of trolley Y before the collision is 0. And how can we find the momentum after the collision? So the momentum after the collision is the mass of X plus Y. So they are now stuck together. So the momentum after the collision is the mass of both of those trolleys stuck together times the speed in which they're moving at, which is what we're trying to find. Okay, so let's just keep substituting in here. So that gives us 0.0065 is equal to the mass times the velocity. So our mass after the collision is 0.133 plus 0.046 times that velocity. That gives you your momentum. Okay, so let's add those masses together. Okay, so that means that 0.179, the combined mass of both, times the velocity, that gives your momentum after the collision, and it's equal to 0.0065, the momentum before the collision. Okay, so your momentum before the collision is equal to your momentum after the collision. We've substituted in our values for the momentum before and our values for the momentum after the collision. And from here, we just need to solve for the unknown value. Solve for your unknown, your V. So how do we do that? Well, anytime I want a letter on its own, I'm going to divide both sides by the value in front of it. So dividing both sides by 0.179 to get V on its own, just like you would do in maths with your x's, and dividing that out, 0.0065 divided by 0.179 gives you a velocity of 0.036 meters per second. Okay, and that's your final answer for that question. I hope that helped. Thank you.